Hey guys, in this video I'll be explaining you the experiment which is used to find out the charge to mass ratio for an electron. So consider this 3D figure. This is a Helmholtz coil. The outer circle is a Helmholtz coil. I'll begin with explaining with the apparatus. And the inner circle, the small one, the small black circle, this is a glass chamber. Okay, I'll come to what the blue circle is. So this is the 2D image of the same diagram, and there is some apparatus A. This rectangle is A. I'll explain you what that A is. Okay, so this is the 2D image of the same thing. So basically, uh, what happens is, consider A. A is nothing but an apparatus of cathode and an anode. Consider this as an anode, a grid-like anode. This is anode, and this is cathode. So what happens is, the cathode is heated. Okay, and there is a potential difference of V across anode and cathode. Okay, and cathode is heated until it releases some electrons. So what happens is the cathode releases some electrons. Since there is a potential difference V, the electrons will travel towards the anode and eventually enter into this glass chamber. Okay, and what happens is this glass chamber is filled with some gas. Okay, some gas. So when a beam of electrons, when they enter this glass chamber, they travel in a circle. Why do they travel in a circle? Because there's a Helmholtz coil that has a magnetic field which is coming outside of this plane. Okay, so there's a magnetic field which is coming outside of this plane. So the electron faces a force in a direction such that it moves. I'll come to the theory in a while. So the electron moves in a circle. Okay, and why the blue thing? Because it emits a blue light. Uh, depends on the gas actually. So what happens is when electrons collides, the electrons from this beam, when they collide with the atoms inside the glass chamber. Okay, so there are atoms of gas inside this chamber. So when the electrons collide with them, they excite the electrons of those gas atoms, and when those excited atoms come back to the stable configurations, they radiate uh, light. Okay, so that's how you get to see this blue light. Okay, so now let's come to the theory. Okay, so basically what's happening is there's an electron which is being released with a velocity v inside a chamber which has some magnetic field B coming outside of this plane acting upon it. Okay, so first let's see how much velocity the electron has. Okay, so since it is being accelerated through a potential of V, the total kinetic energy of electron will be given by this equation. So this is the total energy, uh, the total potential difference. This is V, and when it goes from higher to lower potential, the potential energy is converted into kinetic energy. So the velocity of the electron is given by 2 eV by m to the power 1 by 2. Okay, so this is the velocity with which it enters this chamber, and since it is having some velocity v, it experiences a force in this direction. Why is that so? Because force on a moving charged particle inside a v is given by this equation, and this is nothing but E V B. E is the charge of electron. Since the velocity and magnetic field is perpendicular, so the cross product is given by VB sine theta, sine 90. So that's 1. So this is your total force that's being applied. So since there's a force perpendicular to the velocity, this electron will start moving in a circle. Okay, which I should actually use a blue color to represent that circle. Okay, so if it is moving in a circle, there's a force here, there's a centrifugal force that comes into play with mv square by r. So basically, I can equate this centrifugal force with this force. So EVB is equal to mv square by r. Okay, so I can equate this. From this, I get my V as EB R by M. Fairly simple. Okay. So now I have two equations for V. This is equation number 1. This is equation number 2. Both are velocities. I can equate them. So E B R by M from equation 2 is equal to 2EV, where this V is capital V, okay, the voltage difference, by M to the power 1 by 2. So squaring both the sides, we get E square B square R square by M square is equal to 2EV by M. M cut with just like this. And so yeah, so here you have E by M as V by B square R square. So now you have an equation for charge to mass ratio of an electron. V is the voltage difference which is set by U. B is the magnetic field which is generated through Helmholtz coil. R is the radius which you measure experimentally to find out this charge to mass ratio. Okay, so how much is this B? Basically, B for a Helmholtz coil is given as mu naught Ni by 5 by 4 to the power 3 by 2 A, where A is the radius. Basically, A is this radius of the Helmholtz coil, and N is the number of turns in Helmholtz coil, and I is the current that is being supplied. So if you substitute your B, you get your equation for E by M. So that's pretty much it. You vary current I, you vary voltage V, accelerating voltage V, and you measure R to get your results. Okay. So basically, I have prepared a simulation using Desmos, wherein I took N is equal to 140 and A is equals to 13.5 centimeters to calculate E by M. So this is the simulation. As you can see, when I vary my current, when I increase my current, the radius of the circle decreases. Okay. And when I increase my voltage, the radius of the circle increases. So this is the simulation. I'll attach the link to the simulation in the description. Okay. And so yeah, that's pretty much it. So this is the theory. If you have any questions, let me know. So thank you.